Sorry. Sheets. Yeah. All right. So I guess everyone can see my screen then. So my name is Ying, and I'm currently a research associate in machine learning, and I'm working in a joint program between the University of Leicester and a tech company called TG0. So the purpose of this program is to design a machine learning architecture for TG0's devices to help them to achieve an accurate gesture recognition. So I will give everyone an idea about how machine learning is used in gesture recognition from industry's point of view. I won't go into too much details about the technical part. Of course, you're welcome to ask me any questions which are technical if you are interested in it. So my company, TG0, designs products with a capacitive sensor for various purposes. The thing is, if you apply capacitive sensor on hardwares of different shapes, the combination can actually extend to a very large variety of applications. I'm going to first show you some examples of these combinations with capacitive sensor. Then I'm going to point out what kind of application would be considered as a gesture. And then I'm going to show you why do we need machine learning for this, and what does the other companies do apart from my company TG0? What do they do with machine learning to their products? In the third part of this talk, I'm going to show you how I started the whole process in a company which has zero experience with machine learning. At the end of this, I want to share some useful links, which can be quite handy if you want to dip your toes into this field. So, of course, first of all, I'm going to say what is a gesture recognition, and more specifically, what is a gesture? So gesture can be anything. So here I'm going to demonstrate a device which gives you some ideas of simple gestures. Like over here, if you slide left, it's a gesture going to left, and slide right, going to gesture go to right. And also, if you press a button, that is a gesture as well. So something, if we make it more specific, and it can be something like I press it with a slight touch, it gives a light strength. And if I press a little bit harder, it gives a very strong strength. And that can be two different gestures. And if we move to a dial, turning left and turning right, clockwise, anti-clockwise, and how much I turn, it can be considered as a gesture as well. Not only it can be shown on the UI, saying that, okay, that's actually how the dial is turned. It can be also translated into a kind of computer language, saying that that's what I want the computer to do. Like anti-clockwise could mean something, and clockwise can mean something else. So the next video I'm going to show you is pretty cool. It's the device I'm currently working on, and it is currently used in virtual reality. I'm going to show you the gaming part of it. So the device you just saw from the last video is called ET. It is a handheld controller. Apart from being used as a normal game controller, it is also functioning as a hand tracking devices. As you can see here, it recognizes your finger movements, and also like it can recognize some simple gesture like point and squeeze, or other things like I think it does soft touch and squeeze and pointing and a little bit shooting gestures. So it already does something like that. So why do I need to use machine learning for this? The thing is, to be able to detect a gesture from these raw signals I get from this device, I need to monitor the signal behavior. And for a lot of our products, what we are doing is like, I perform a certain gesture, and then it recognizes, I start to look at the signal and monitor how it behaves when I was performing this gesture. And with my brand, I start to conclude that, okay, this is kind of pattern my device is doing. Then I'm going to transfer that into a code saying that, okay, if this part of signal performs in this type of pattern, then that means it gives me a gesture of pointing or give me a gesture of squeezing. However, as the devices get more and more complicated, and as the gesture I wanted to get more and more complicated, maybe I want something else. Maybe I want to say zoom in, zoom out. So what do I do with it? Like, it is beyond the human brain's capability to detect or see these patterns from my raw signals. It's just going to be numeric signals and like with numbers. It is beyond the human brain's capability to do that. Now, in this case, machine learning can be very handy. So that's why we need machine learning for these type of gesture recognition. Of course, there are probably hundreds or thousands of companies which want to use machine learning for their sophisticated devices. I know one of the hot topic is actually self-driving cars. If you think about it, a movement of a car in front of you could be indicated as a gesture as well. If the left light is flashing, that means they're going to turn left. And if the right light flashing, that means they want to turn left. If you flash the warning light twice, I think that means, oh, thank you. I hope I'm all right. I'm right about this. And if you see a car wiggling on a motorway and they can't keep within the lane, it probably means the driver is drunk or drugged or having a fight with the people who's sitting next to them. So yeah, like it's all these things means can be classified as a gesture. But unfortunately, I'm not going to. I'm not working in self-driving cars, so I'm not going to dig deep into this. I want to show you one of the products Microsoft is working on, and I find it really cool and challenging. And I don't work for them though, but so sorry. Yeah. So all the videos and pictures I got are actually from their website. So I don't know if there is going to be copyright problems if we're recording this presentation, but I hope it's not. It's all from their website. So the product is called Hololens. So what does it do? It is type of goggle. It has a glass in front of your eyes, and on the top of it, that's a processor and battery and everything, and has several cameras on top of it. These are the cameras which record the environment. So what it does do, there is multiple applications of it. You can use it for education purpose or in industry. So through these glasses, which is see-through holographic lenses, you can see the environment around you. So it doesn't, it's not like a solid goggle, which you see the outside world through the cameras. You actually see them with your eyes because they are glasses. But at the same time, they are holographic lenses, which means they create holographic image in front of your eye. And it creates these virtual objects. On the right picture, you can see that, okay, it creates something, I don't know what that is like, but some maybe a biological tissue object thing. And the thing is, it looks like a 3D model in front of you. And the purpose is to mix this virtual object with the reality to create mixed reality. And the thing is, also the application would be, if you look at something in front of you, it's right there. If you look from the side, the object doesn't move with your movement. If you look at it from the side, it would actually make it look like the object is actually there. You're just looking at it from the side. What else do they do? Like, there are several parts of this goggle. Actually, I think they involve machine learning. So the first of it, like, of course, the part I'm interested in the most is the hand tracking features. So in a recent machine learning conference, the Hololens machine learning team actually published and showcased their techniques of generating training data for this hand tracking. I'm going to go into details later. So what they do is, when you have a hand in front of the goggle, the cameras record your finger movements, or record actually the videos of your hands. And so they use machine learning to process all these images and recognize how your finger moves. So that's one of the functions they have. I don't know if they do body tracking with these cameras, because I know that Google and Apple, they are actually doing the body tracking system. So they have a ready model, so you can download online. So technically, Microsoft has ability to do that because they have cameras, basically. If they implanted these type of machine learning model into their processor, they can actually do it. So they probably have these type of functions to do hand tracking and body tracking. So they also have other functions. The next thing I'm going to show you is called kind of a eye tracking system. It's a video downloaded from their website, so I hope it's not a copyright problem. So what they do is that they have cameras to track where your eyesight is focusing. In this case, they know what you are looking at. So it will be something like if they know where you are looking at, so they know where the object should be, like which side you are looking at regarding to the object. In this case, actually, the similar technique was applied in another product called Oculus as well. This is a product from Facebook. It is a type of goggle as well. It has cameras in front of the goggle. It's not transparent. It doesn't have transparent lens. It is just pure solid goggle. Like the normal gaming goggle you can see in the market. They also have this eye tracking system. What they do is they track where you look at, and it knows, if it knows what you're looking at, then it starts to do this rendering of the image you are looking at. Something like what you see from these two pictures. So the red square represents where your eye sits. If your eye are focusing on the screen in front of you, then it will sharpen the image of the screen. And if your eye focus on the background, then it will sharpen the background and make the screen a little bit blurry. So it makes it look a little bit like real, like in a 3D environment, instead of kind of 2D environment, but they make it look like a little bit 3D. So they want to make it more realistic. This is a deep focus rendering system Oculus is doing with machine learning. So because if what they are trying to do is like, if you make it look more realistic, it will help the user to conquer the thinking that, okay, I'm just in a virtual environment. It make it realistic, make the user feel more comfortable. Because when I use these goggles, I always find it a little bit nauseous because it didn't trick my brain thinking, okay, that's the real environment, because it confused my brain that caused this kind of confusion and caused the nauseous part. So what all these companies are trying to do is make it more realistic, making it more comfortable for users to do and to actually use them. Then the next function I want to mention in HoloLens is kind of 3D mapping. So it has a spatial mapping to map out the distance of each object, and then record the shape of this object. Think about it. If the processor knows what the environment looks like, and then it will be much easier to create a virtual object on top of it. Because think about it, in front of you, that's a table, and I want to create a virtual object on top of the table. Then I know exactly where I'm going to put it on. And if I move my position from the front of the table to this left of the table, it knows what it will be rotating. So the HoloLens. The goggle knows where to put the virtual object and how close you are to the object and which direction you are looking at. And I think, I don't know if they actually put machine learning, but I believe there is something which machine learning could help in this case, because there is another company who does similar things. So this is a company called Magic Leap. This is also a Google company, and that's like where my research is focusing on recently. So I'm going to show these as an example. So what it does is it has a very similar technique. It uses spatial computing to calculate how close each item is. And by doing that, it knows the shape of the object and how close they are to you. And but instead of maybe they put a virtual object in this environment as well, but also they put kind of artificial light into the object as well. Because if you think about it, how do you decide how close an object to you? Of course, human has like 2 eyes, so we have the ability to calculate the distance in our subconscious. We can roughly estimate how far is like my laptop is close to me, because with my 2 eyes I can calculate in my subconscious, I think. But it's not just because we have 2 eyes. It's also because how the shadow works, how light is interacting with an object to make it more realistic. You think about it, if you are living in whole environment of black and white without lighting, it might be a little bit hard for a person to calculate how far it is an object is to you. So these calculations are based on light, shadows, and also maybe the resolution of these images. So if you know, like I have a virtual object in the middle, it has no shadows, then how real it is to me. What Magic Leap does is it puts a virtual light to these objects to make it more real. And in this case, it makes the virtual environment more realistic as well. So in this case, it's actually very similar to what HoloLens does. Also, Oculus can do that as well. Oculus was a goggle I mentioned earlier, which was a company from Facebook as well, because they all have these cameras to record the environments. And then they can actually calculate or create a 3D mapping of the environment as well. They all have this potential. So my next question would be, we've seen all these cool applications we can achieve with machine learning, but how do we actually start with this process? So to make it easy, there are only 3 parts you need in your machine learning architecture. If you are new to this machine learning fields, or you want to just apply these into your project, that's the part you need. We have an input machine learning model and an output. But there's so much we can talk about it. I'm going to give a blank page to this input and output because it has, like, for me, it's the most difficult part, because for different devices, for different applications, and for various companies or organizations, the input can be hard, can be really, really hard, and also can be simple. If you think about what HoloLens has, the goggle from Microsoft, I mentioned they have a machine learning team who talked about it in a CVPR conference earlier this year. Also, they mentioned it last year as well, actually. So what they do is, like, to be able to detect this hand tracking, you need images from your goggle, from your camera. So that is what pictures after pictures. It's a video, probably like, I don't know, 24 pictures in 1 second. So you need these pictures to know, okay, that's my input information. But what is the output? I have a picture. How do I know what my finger, with the position of my finger? If I can draw it directly from this picture, I don't need the machine learning model. And how do I do it? What they did was to generate a virtual model of hand. So they have this kind of like it's like creating, again, having 2 hands or with arms in front of you with all these hand skeleton, and then give it a little bit muscle, give it a little bit skin, and give it a little bit background. I create these kind of hands in my game, and you look at it from the point of view from your eyes. So the computer knows where the hands are because I created them. Then the next problem is going to be, okay, I'm going to take a picture, or not a picture, I'll record the model. And then in this case, I have my input. I have an image, or kind of where the virtual camera is to record the position of my finger or my hands. And I know the output because I create the model, so I know what my hand skeleton is. So they were creating the input and output from their machine learning team. With different styles, your hands can move. Then in this case, they can generate thousands of, maybe, well, like thousands of hundreds or like of data. Of course, the problem they are running into is not just that. Apparently, if you put a little bit jewelries or a ring, a bracelet, a little bit painting on your hand, it will cause confusion. Also, changing a background will cause confusion as well. So it is a little bit hard for machine learning models to learn it, to generate an accurate output. So they need to create more models with jewelries, bracelets. and even the sleeves. So they have an arm as well, and on this arm, maybe changing the watch, changing how long your sleeves are, is going to affect the result as well. Of course, that's the problems they are running, or they have during their research, and they told us about it. Something like my problem is actually I have loads of messy data, or non-data, like I don't have any data, I could say that. So because, as I told you, my company had zero experience in machine learning before I actually joined them. So what they do is like, they have the device, they don't have input data. Then how do you create these thousands of thousands of gesture data for the gesture recognition? And not just that, how do I actually have an output from this gesture input? Like if I perform gesture, how does computer know I'm performing this gesture? All these need to be created beforehand, before actually going to the part of model. I also had a very interesting talk with a professor in NGS today about how they actually having with their input data. The problem of their data is there are way too much data, way too many data. What they told me is that they have a data collected for probably the past 10 years every day. And they have like data from hundreds of systems in the NHS system in just one hospital. And they record that every day. They put them in a database for, I don't know, 10 years. That's lots of data sitting there. And even the professor who has been in the field for, I don't know, like 20, 30 years, he couldn't figure out what each data set means. So they have a large amount of input data, but very messy. So there are so many problems coming with this input and output. And I'm not going to go too far about it because there are like hours. Like I can talk hours about how difficult and how much pre-processing I have with this, and also like not mentioning natural language processing and other things, or handwriting as a nightmare as well. I'm going to move on to the next, machine learning models. I think that'll be a little bit fun part. So there are so many machine learning algorithms out there. How should I choose? If you're new to the field and want to apply machine learning in your project, this could be a nice figure to look at. There are so many versions online there. Just search with the keyword of a machine learning cheat sheet. As long as you know what kind of problem you have. And then you can easily find the type of model which suits you. I remember there was a saying that 99% of the problem in the market can actually be solved with a simple machine learning model, which you can find that in the chart. Something like if you have less than 50 samples, then you need to get more data, apparently, because machine learning requires large amount of data. Then if you have more samples and then decide whether you want a category, and if you have a category, and you basically want a classification, the next step is whether they are labeled. And if you don't want category, and are you looking for regression problems or a dimensional reduction problem? Do you want to extract the features of your product? Do you want to give it a score, like have like a numeric value saying that, okay, ranging from 0 to 100? Or whether I have no idea, I just want to classify my data into several clusters. There are so many models you can go into, and because the field is so developed now, you can easily find these models in some library. something like sklearn. So if you know a little bit better about machine learning, and you can dive into the world of neural networks. So if you think about how human brain works, our brain works in a huge network with millions of neurons. So our neural networks will be kind of something which mimic that. And the funny thing is, a simple neural network would be like just 3 layers with several neurons, not even like over 10 or something. But you have if you have like over 2 layers or 3 layers, like a little bit like in this case, like 6 layers, it will be called a deep neural networks for the computer that's deep enough. And then ideally, like theoretically, actually, if you have enough neurons, which mimic how the millions of neurons in your brain, theoretically, we are saying that, okay, you can actually do what a human brain can do. But that is also limited by our computing capability of all these computers or cloud computers as well. But if you think about it, it's actually not too simplified. We just have an input on the left side represented by my purple dots. And then we have a certain type of orange dot, which are my output. So I just create all these types of neurons in the middle. Like creating a model is basically arranging how the neuron layered in a simple way. Like, of course, there are other things which can be connected in different ways, but like in a simple way, we can just add the neurons in a different layer, and with a little bit different arrangement. One neuron can talk to another, and all sorts of things. But eventually, what we are trying to do is going from an input to the output with a model in the middle. So yes, then that's what we have. An input, a model, and output. If you want to start with machine learning, that's basically all you need. Input and output and model to start with. Of course, if you want to apply machine learning into your project, and you already have a lot of input data, a lot of training data you have in hand, and you know what they are, you have them labeled, you have the corresponding output for each input, that'll be quite straightforward to have your own machine learning architecture. There are some shortcuts I would recommend to you, because you don't even need to design your own machine learning model. There are so many resources online. I'm just showing you some examples from TensorFlow and the Google website and Apple website, and there's so many more. You can just search online, say that, like Google model and machine learning model and Apple machine learning model, or just machine learning model with the cool company you think of. And then they have a lot of models to do translation for the natural language processing. And they also have this hand gesture recognition. Sorry, not gesture recognition, hand recognition, hand position, finger position recognition, body recognition. They also have something like voice recognition as well. A lot of resources. You don't even need to develop your own. As long as you know what your problem is, find the corresponding model online, and then put your input data into it and try it out. So yeah, like that's all I can like show you guys today with how to dive into the machine learning field. And thank you very much for this talk. If you have any questions or even technical questions you want to ask, welcome to drop me an email. All right. I'm going to hand this to you.
Thank you very much, Ying. Does anyone have any questions they would like to ask now? You can either unmute yourself or drop a message in the chat.
It can be any questions, like I'm trying to make it more general, so the topic would be applied to everyone who wants to know a little bit about how machine learning is applied. So it doesn't have to be like machine learning related question either.
I can start with a question. Can you recommend, well, do any open source frameworks for this problem exist? And if so, could you recommend something?
You mean for gesture recognition?
Yes, yeah.
So far, I didn't see any ready model for my case, because for my device, for the device in TG0, it's specific type of signal. And if I find one, I can probably apply for it. The thing is, the gesture is not always the same, not always like the gesture from the model, like online model might not be the same. I can tweak about it. And to basically, I can use their model and tweak a little bit of the model to generate the gesture I want. But the biggest problem in my project is not going with the model, actually. It is going with the input data. First, I don't have enough input data, which is always essential in a machine learning problem. And the second of all is that my data is quite messy. So is my outputs for my input data are actually accurate? Am I giving the training part enough accurate data? That's going to be another problem I need to solve.
Actually, talking about that, I know in machine learning on images, like when you don't have enough input data, you distort some of the images, you rotate them, you add some noise, something like that.
Yes.
Can't you do something like this with gestures?
Yeah, that's actually very good. That's what I am doing with these as well. So there are certain things I can do to multiply the amount, like to expand the amount of the data I have. At the same time, I also need to kind of collect enough to be able to make them expand enough as well. And also by doing something like that, like playing with the raw signal also introduce a problem of this artificial noise, or I would say artificial noise is like kind of this artificial error, which if I play with it, is that going to recommend my real data successfully? With image is something, you know, it's a part of image. If you turn it around, you know, it's not going to change the kind of the property of image or the details of it. But with actually numerical signals, it might it might affect it. So they are all something we need to test and analysis in this case. Yeah. Thank you.
That is very interesting. How do I volunteer to submit more data into your training sets?
Yeah, that's actually we are I'm actually also running a kind of project for students in university to recruit students to collect these data. So there's all sorts of ways, like to trying to get a lot of numbers of people to help collecting all these data. I think that's probably the problem for a lot of companies who want to use machine learning for their devices as well.
That's very nice. Thank you very much. Does anyone else have any questions? Okay, I take it as a no. Thank you all very much for attending today. Thank you, Ying. It's been a pleasure to listen to you. Machine learning is super important, and it's even more important that we have ethical people doing machine learning, because that's our future, let's be honest. So yeah, Please do get in touch if you remember any questions. Yin is also available on our Slack, by the way. So thank you all.
Thank you. Thank you, everyone.